Good morning students. Welcome to 11th standard chemistry video class. We are discussing lesson 10 chemical bonding. In our last video class we completed up to the definition for covalent bond and formation of covalent bond in hydrogen molecule, oxygen molecule and nitrogen molecule. In this video, we will start with the next topic representing a covalent bond using Lewis structure or Lewis dot structure. Representing a covalent bond using Lewis structure or Lewis dot structure. Here, covalent bond formed between the combining atoms is given by pictorial representation. It is said to be Lewis structure or Lewis dot structure. We are having two types of valence electrons, namely shared valence electrons and unshared valence electrons. The shared valence electrons are otherwise called bond pair electrons, which means the electrons involved in the bonding. Hence, they are represented as a pair of dots between the combining atoms. The unshared valence electrons are otherwise called lone pair electrons, which means the electrons not involved in bonding. Hence, they are represented as a pair of dots on the respective individual atoms. The Lewis dot structure for a given compound can be written by the following steps. Let us understand these steps by writing the Lewis structure for water. Here, the following steps will explain how to write Lewis structure for water. It involves 5 steps. Let us discuss one by one. Step 1. Draw the skeletal structure of the molecule. In the first step, we have to give the skeletal structure of the given molecule. In general, the less electronegative atom is placed at the center, where hydrogen and fluorine atoms should be placed at the terminal positions. Here, water with formula H2O. For water, the skeletal structure is given here. It is written as HOH. Step 2. Calculate the total number of valence electrons of all the atoms in the molecule. In the second step, we have to calculate the total number of valence electrons of all the atoms in the molecule. In case of polyatomic ions, the charge on ion should be considered during the calculation of the total number of valence electrons. In case of anions, the number of negative charges should be added to the number of valence electrons, where anion is considered as negatively charged ion. In case of positive ions, the total number of positive charges should be subtracted from the total number of valence electrons, where cation is considered as positively charged ion. Here we are discussing water molecule. The calculation of total number of valence electrons of all the atoms in the water molecule is given here. In water molecule, it contains 2 hydrogen atoms and 1 oxygen atom. In water, the total number of valence electrons is equal to 2 into 1 plus 1 into 6. Here, in this 2 into 1, the 2 represents number of hydrogen atom, where 1 represents number of valence electron in hydrogen. In this 1 into 6, the 1 represents number of oxygen atom, where 6 represents number of valence electrons in oxygen. Therefore, 2 into 1 plus 1 into 6, which is equal to 2 plus 6, which is equal to 8. Therefore, total number of valence electrons in water molecule is equal to 8. Step 3. Draw a single bond between the atoms in the skeletal structure of the molecule. In the third step, we have to draw a single bond between atoms in the skeletal structure of the molecule. In the skeletal structure of water, we have to draw a single bond between hydrogen oxygen and oxygen hydrogen. Hence, we placed two single bonds. It is shown here. Each bond contains two electrons. In water, it contains two bonds. Therefore, it contains 4 electrons. Step 4. Distribute the remaining valence electrons as pairs. That is, lone pair giving octet to the atoms in the molecule. Only do it for hydrogen. Already we discussed that the electrons which involving in bonding is said to be bond pair electrons, where the electrons which do not involving in bonding is said to be lone pair electrons. Here hydrogen follows duet configuration, that is 2 electrons, while other atom follows octet rule configuration, that is 8 electrons. Here we have to distribute the lone pair electrons to the most electronegative atoms followed by the other atoms. In water, totally we are having 8 valence electrons. Among the 8 electrons, 4 electrons are used in bonding. Remaining 4 electrons are there. It is considered as 2 lone pair electrons, and it is placed on more electronegative central oxygen giving octet. It is shown here. The 2 lone pair electrons are placed on oxygen atom. Step 5. Verify whether all the atoms satisfy the octet rule and for hydrogen duet. In this molecule, we have to check whether all atoms other than hydrogen contains 8 electrons, where hydrogen contains 2 electrons. If not, use the lone pair electrons to form additional bond to satisfy the octet rule. Here, in this structure, each hydrogen atom contains 2 electrons and oxygen atom contains 8 electrons. Hence, there is no need for shifting the lone pair. Finally, the Lewis structure for water molecule is shown here. Using the 5 steps, one can able to draw the Lewis dot structure for the given molecule. Hence, we completed Lewis dot structure for water molecule. Next, we have to discuss Lewis structure for nitric acid with the formula HNO3. First, we have to draw the skeletal structure for nitric acid. It is shown here. Hydrogen, oxygen, nitrogen, oxygen. Below nitrogen, we have to place oxygen. Next, we have to calculate the total number of valence electrons in HNO3. In HNO3, it contains 1 hydrogen, 1 nitrogen and 3 oxygen. It is given by 1 into 1 plus 1 into 5 plus 3 into 6. In 1 into 1, the 1 represents number of hydrogen and another one represents number of valence electron in hydrogen. In 1 into 5, 1 represents number of nitrogen and 5 represents number of valence electrons in nitrogen. Next, in 3 into 6, the 3 represents number of oxygen and 6 represents number of valence electrons in oxygen. Therefore, 1 into 1 plus 1 into 5 plus 3 into 6, which is equal to 24. Therefore, total number of valence electrons in the nitric acid is equal to 24. Next, we have to draw single bond between atoms in the nitric acid. 4 single bonds can be drawn between hydrogen oxygen, oxygen nitrogen, nitrogen oxygen, and again nitrogen oxygen. It is shown here. Hence, it contains 4 bonds. Therefore, it contains 8 electrons. Next one, distribution of remaining valence electrons as pairs, that is lone pair. Here, we have to distribute the lone pair electrons to the most electronegative atom followed by other atoms. In nitric acid, totally we are having 24 valence electrons. Among the 24 electrons, 8 electrons are used in bonding. Remaining, we are having 16 electrons. It is considered as 8 lone pairs. Hence, these 8 lone pairs to be distributed in oxygen atom. 3 lone pair is distributed in 2 terminal oxygen and 2 lone pair electrons is distributed in central oxygen in order to satisfy octet or 8 electrons. In this distribution, the nitrogen has 1 pair short for octet or 8 electrons. Hence, move one of the lone pair from the terminal oxygen to form another bond with nitrogen. It is shown here. If we check, except hydrogen, all other atoms having octet configuration are 8 electrons, where hydrogen having duet configuration are 2 electrons. Hence, the Lewis structure of nitric acid is shown here. Hence, we completed the Lewis dot structure for nitric acid. Similarly, the Lewis dot structure for some molecules are given here. The molecules are sulfur trioxide with the formula SO3, ammonia with the formula NH3, methane with the formula CH4, and dinitrogen pentoxide with the formula N2O5. Next topic, formal charge. Why we have to introduce the topic formal charge? For a simple molecule, it may be present in more than one acceptable structure. Which structure represents the best distribution of electron in a molecule, or which structure is more preferred? In order to find the answer, we have to know the formal charge. It is explained by taking an example. Consider carbon dioxide. The formula is CO2. First, we have to draw the Lewis dot structure for carbon dioxide. Already, we discussed the topic how to draw Lewis dot structure. First, we have to draw skeletal structure for carbon dioxide. It is given as oxygen, carbon, oxygen. Next, we have to calculate the total number of valence electrons in carbon dioxide. Here, we are having 1 carbon and 2 oxygen. Therefore, it is given by 1 into 4 plus 2 into 6. Here, in 1 into 4, the 1 is number of carbon, where 4 is number of valence electrons of carbon. Next, in 2 into 6, the 2 is number of oxygen, where 6 is number of valence electrons in oxygen. Therefore, 1 into 4 plus 2 into 6, which is equal to 16. Therefore, the total number of valence electron is equal to 16. Next, in the skeletal structure, we have to draw a single bond between oxygen carbon and carbon oxygen. Hence, there should be two bonds. Therefore, it contains 4 electrons. Next, distribute the lone pair electrons in most electronegative atom followed by other atoms. In carbon dioxide, totally we are having 16 valence electrons, in which 4 electrons are used as bond pairs. Remaining, we are having 12 electrons. It is considered as 6 lone pairs. Hence, 6 lone pairs are distributed to the 2 terminal oxygens. To satisfy octet, distribute each oxygen 3 lone pairs. It is shown here. Finally, we have to verify whether all atoms in the molecule satisfy octet configuration. In this distribution, the central carbon has 2 pair short for octet. Therefore, to satisfy the octet rule, 2 lone pairs from one oxygen or 1 pair from each oxygen can be moved to form multiple bonds, leading to the formation of 2 possible structures for carbon dioxide, which is shown here. Here, structure 1 is due to movement of 1 lone pair electrons from each oxygen, where structure 2 is due to movement of 2 lone pairs from one oxygen atom. Hence, for carbon dioxide, there are 2 possible structures. Among the 2 structures, which one is more preferred? It is found by calculating the formal charge. Here, we are having the definition and formula for formal charge. Formal charge of an atom in a molecule is the electrical charge difference between the valence electron in an isolated atom and the number of electrons assigned to that atoms in the Lewis structure. Therefore, the formula to find the formal charge of an atom is given by Nv minus of Nl plus Nb by 2, where Nv is number of valence electrons of atom in its isolated state, where Nl is the number of electrons present as lone pairs around the atom in the Lewis structure, where Nb is the number of electrons present in bonds around the atom, that is bond pairs in the Lewis structure. Simply we can tell Nv is nothing but number of valence electrons, where Nl is nothing but number of lone pair electrons, where Nb is nothing but number of bond pair electrons. Now let us calculate the formal charges on all atoms in the molecule for both structures. For structure 1, formal charge on carbon is equal to Nv minus of Nl plus Nb by 2. Here Nv equal to 4, Nl equal to 0, Nb equal to 8. Substitute the values. Therefore, 4 minus of 0 plus 8 by 2. After simplification, we will get 0. Next one, formal charge of oxygen. Here, Nv equal to 6, Nl equal to 4, Nb equal to 4. Substitute the values, we will get 6 minus of 4 plus 4 by 2. After simplification, we will get 0. Therefore, formal charge for both oxygen is equal to 0. Hence, we calculated the formal charges for carbon and both oxygen in structure 1. Next, for structure 2, we have to calculate the formal charge. In structure 2, for calculating the formal charge on carbon, Nv equal to 4, Nl equal to 0 and Nb equal to 8. Substitute the values in the formula. Nv minus of Nl plus Nb by 2. We will get 4 minus of 0 plus 8 by 2, which is equal to 0. Therefore, the formal charge of carbon is equal to 0. Next one, formal charge on singly bonded oxygen. It is given by 6 minus of 6 plus 2 by 2, which is equal to minus 1. The formal charge on triply bonded oxygen is given by 6 minus of 2 plus 6 by 2, which is equal to plus 1. In structure 1, all the individual atoms, that is both oxygen and carbon in the molecule, have formal charge value 0. But in structure 2, formal charge of carbon is 0. The formal charge of singly bonded oxygen is minus 1. The formal charge of triply bonded oxygen is plus 1. It is shown here. After calculating the formal charges, the best representation of Lewis structure can be selected by using following guidelines. First point, a structure in which all formal charges are 0 preferred over the one with charges. Second point, a structure with small charges is preferred over the one with higher formal charges. Third point, a structure in which negative formal charges are placed on the most electronegative atom is preferred. In case of carbon dioxide structure, the structure 1 is preferred over the structure 2, as it has 0 formal charges for all atoms. From the above conclusion, it is understood that structure 1 is preferred over the structure 2. Since in structure 1, all the atoms in the molecules contains the formal charges value 0. Let me stop up to this topic. The remaining that we will discuss in our next video class. Thank you.